All right, we'll try this again. Solving exponential equations. So last week we learned how to solve things like, if we had 2 to the x equals 2 to the fifth, you could solve that one. You said x equals 5. Now we're going to get things that are going to be, they're not going to be equations that you can put in the same base. Although you can solve these ones where you have the same base, you can solve these with this method I'm going to show you. And so, for example, 7 to the 3x equals 20. So I'm not going to be able to get this equation to look like 7 to the 3x equals 7 to the something, because 7 to the something won't give me 20. So here's the technique that I use. And this is a technique for solving equations that has as their exponent the variable. So you've got some kind of variable up here in the exponent, right? So this is the technique that we use. And essentially what I do is I log base 10 both sides of this equation. Okay, so this equation becomes the log base 10 of 7 to the 3x. Remember, I don't write the little 10. Equals log base 10 of 20. As simple as that. Why do I do that? Because one of my properties of exponents says that if I've got one of my properties of logs says that if I've got a number to power to an exponent, I can bring that exponent outside the log, and that's what's going to help me isolate this x. So this log base 10 of 7 to the 3x is 3x times log base 10 of 7. Now, the reason I do log base 10 is because I can just punch log base 10 of 7 into my calculator. I can just punch log base 10 of 20 into my calculator. So I'm going to write this one out fully before I punch it in my calculator. I'm trying to isolate this x, so the first thing I'll do, or the next thing I'll do, is divide both sides of this equation by the log base 10 of 7. Those cancel, and I get 3x equals log base 10 of 20 divided by log base 10 of 7. Divide both sides of this equation by 3. And x is the log base 10 of 20 divided by the log base 10 of 7. All of that divided by 3. So let me show you how you put this in your calculator. This is an exact answer here. In your calculator, you would go log. When you hit the log button in your calculator, it automatically puts up a parentheses. You'll put that 20 and be sure to close the parentheses. Divided by, hit the log button again. It comes up with the parentheses again. You put in the 7 and then close the parentheses. And we're going to divide that whole thing by 3. In order of operation, we'll keep that nice and clean for us. Divided by 3. So this answer is exact, but now we'll get an approximate answer in our calculator. And my calculator says, and hopefully yours does too, 0.513, I can't read it now. Hang on. 0.51316. Okay, all right. So I want to round to 4 decimal places. So I look at the fifth decimal place, that's a 6. So that means I take the 4th decimal place and I round it up to 2 and I get rid of the 6. So now I've rounded to 4 decimal places, 0.5132. Okay, would you like to see that done again? I would hope so. Otherwise you're lying. So we'll do 3 to the x plus 4 equals 101. First step is to log both sides of this equation. So this is the log base 10 of 3 to the x plus 4 equals the log base 10 of 101. Bring the x plus 4 outside of the log, and I always put that in parentheses to remind me that what I have to do next is going to be a division to go with to be the opposite of a multiplication, or the inverse of a multiplication. So this is x plus 4 times the log base 10 of 3 is equal to the log base 10 of 101. Divide both sides by log base 10 of 3. Those cancel, and I get x plus 4 equals the log base 10 of 101 divided by the log base 10 of 3. To finish solving for x, I'll subtract 4, and x is exactly the log base 10 of 101 divided by the log base 10 of 3 minus 4, which is approximately, I'll put it in calculator speak for you, log parentheses 101 close parentheses divided by log parentheses 3 close parentheses minus 4, which is, this time I'll throw it in my calculator, log 101 divided by log 3 minus 4. 0.20086. I want to go to 4 decimal places, so I write down 5. That 6 means that 8 bumps up to a 9. Get rid of the 6 now, didn't really need it. So that is approximately 0.2009. Okay, so let's see how to use this in an application. So let's say you deposit in your bank account, and this time you're going to get actual compounded interest. We'll deposit $1,000 in a bank account and not touch it, not take any money away, not put any money in, and the account pays, let's say, 8% interest. And my question is going to be, when will you double your money? Pays, yeah. When will you double your investment? Okay, so I'm going to make an exponential equation. Remember, y equals a times b to the x. A is the y-intercept, or the initial amount. That's 1,000. B is the multiplier. We're getting 8% interest, which means we have an increasing function, so I add 8% to